Okay, this is the video to demonstrate how you'd use algebra tiles to demonstrate a few polynomials. We also going to look at how you'd add and subtract polynomials, and also how you would do multiplying binomials with these. So these will link in very closely with IXL objectives, and the first one we're going to look with is currently Z2. So when we say what do we represent by these tiles, then the fact that we're looking at is each of the tiles has some designation on it, either a number, an x, or an x squared. So when we're looking at this picture, I noticed that the squares, the big squares, have x squared on them, and I noticed that there's 4 of them. So I noticed that I have 4x squared. Now the advantage of this is when it's written out longhand, x squared plus x squared plus x squared plus x squared. If students only remember part of the rule of adding exponents, then they could easily put for this question x to the 8. When you realize there's 4 of a certain item, then it's much easier to make that connection. Now, when we move on to the rectangles, we notice that there's 8 of those. So 8x. So I'm putting positive 8x to show that it's not subtract 8x or negative 8x. And I also have 3. And once again, I would have positive 3. And that's how I can represent that. Now, you can't do this on the IXL exercise, but you can actually move tiles around when they're actually manipulatives, which sometimes makes them easier to count. You can put them in different orders, and they're sometimes a little easier to group. And you can see that there's 4, 8, and 3. So sometimes that's another advantage of using tiles. Now you can also have tiles that are negative as well. And sometimes they're shown by either shading, or sometimes they're written on by the tile like this. So I noticed I have 3 of this tile, and they also say negative x squared. So that would denote negative 3x squared. I have 5 of the tiles that denote x, so I'm going to put positive 5x. Of course, if it's negative, you'll see the negative sign here. And I've got 2 of those ones. They both say negative 1, so negative 2. And that's currently the objective Z2 on IXL. Now, when we get to adding, and you can see here, they can be adding or subtracting depending on what sign's here. On IXL, they tend to actually write the question above, and that is a question that you certainly have to be able to answer as well. They could give you the question algebraically, or they could give you the question in terms of a tile. They don't normally give you both, but IXL does. So as I'm looking at this, I'm looking for those like terms. So I'm seeing the big squares here. 1 square and 2 big squares is 3 big squares. 2 rectangles and 3 rectangles is 5 rectangles, and a rectangle is x, and 1 plus 4 equals 5. Now, if you actually have the manipulatives, or you can draw these out, kind of the advantage is you can start to rearrange these terms again. So you can see that there's 3 squares here. I can see if I bring all my rectangles together, whoops, 1, 2, 3, 4, 5, and 5. So some people actually like to draw these as well to help them get a grasp of the conceptual idea before they do the real questions. If I am doing this by hand, notice 1x squared plus 2x squared gives me 3x squared. Whoops. Not sure what happened there. There we go. 2x plus 3x is 5x, and 1 plus positive 4 is positive 5. So you can do it the algebraic way as well. And this one's a subtract. So I got 4x squared, take away 1x squared, which will leave me 3x squared. I have 5x, take away 2x, which is 3x, so positive 3x, and 4 take away 1, which is also 3, so positive 3. Now, some people have done this before when they subtract. You can subtract things from both sides, and it helps to balance things out. So if I get rid of an x squared from this side, I can get rid of an x squared from this side, and it leaves me just 3, making it easier to count. If I lose 2 x's from both sides, I get left with 3 x's. And if I lose a 1 from each side, you can see I get left with 3 as well. So there's a couple of different ways that you can do these questions. This time, I did not give the algebraic one across the top. So that was section Z3. This is Z7, where we're looking more at multiplication questions. Now, the first thing I want people to notice when they do this is the connection to the FOIL type questions that we've been doing, in the fact that the grid is kind of split up into 4 sections. You got your number of x squareds in the top left, which we always have. We have our x's in the bottom corner and the top corner, and normally we'd put our loop here. And then we have our numbers in the bottom corner. So this links in with that multiplication question. Now, they don't always label the tiles as x squared though. Sometimes you've got to figure out that's what's going on by when they label x on the side. So the reason this is x squared is, whoops, let me go to my pen instead, is that it's x times x. So the length of this side here is x, and therefore this length will also be x. Now this rectangle is x, and the reason it's x is it's x times 1. And we can see the 1 here at the bottom here as well. The 1 is actually just 1 times 1. So you could actually label the lengths of all these sides as we're going along. So what question I'm actually answering here is 2x plus 4 times by 2x plus 1. So as I'm working out what these questions are, I'm going across the top and then the side. So I'm doing base times height, because it's an area question. The number of squares denotes the number of x's. The number of rectangles denotes just a single number. And then the same down the side. 2 squares, 2x, 1 rectangle, 1. Now the question also could ask you, talking about the area, so what expression do these represent? I can collect terms together like I did previously. So I got 4x squares, I have 2x and 8x, which gives me 10x, and then I got 4 single ones, which is 4. And notice I didn't actually need to draw the grid out, I could actually use the picture to help me work out what that expression is. So sometimes it's a little bit quicker to do that. This time we've got a multiple choice question, just so we can see where this comes from and to practice this part here. I think actually that's the wrong question that's written down at the top. Yeah, I hadn't noticed that originally in my notes. This is supposed to be 2 squares, which is 2x, and 3 rectangles, which is 3. And down the side, I've got 1 square, which is 1x, and I've got 1. So actually this question is slightly the wrong way around. So let me fix that question right now. Now, in terms of, I'm supposed to say subtract, not equals. All right, let's try again. So when I'm trying to find the area model, let's look how many x squareds I've got first. So I can see 2x squared. So it's not these two answers, because they both said 3x squared. I have 2x's and 3x, which together would give me 5 of those, which I think does confirm it's that answer, not 6. And I have 3 1s, which you can also see is correct for that one too. And actually, I think as I was copying across, that totally says the wrong question. So let's use the area model. This question is trying to work out 1 square, which would be x. I have 4 rectangles. Down the side, I have 1 square, and I have 2 rectangles. So the question I'm trying to work out here is x plus 4 times x plus 2. And I can see that it's x squared. 4x and 2x give me 6x. And 4 and 4 give me 8, and that would be my answer. So no multiple choice this time, this could just be a type-in question. And the advantage of being able to see this in terms of tiles is when we get to our next unit on factoring, this will become a lot more helpful in trying us to work backwards. When we're given a question like this, can we figure out what the 2 factors are? And we can use the property of that area model to help us to do that.